Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we look at the binomial theorem. The binomial theorem, as we discussed in the last lecture, is used to expand binomials. As I said, doing a plus b to the 0 power, we know that's 1. A plus b to the first power is not hard. And a plus b to the second power is not a big deal. But when you get to the third, the fourth, the fifth powers, and you have to write 4 or 5 of those expressions out and multiply them together, it can get pretty lengthy. So, some things to note about the binomial theorem. The first thing is that the first term is a power of a to the n that decreases as you go forward in the expansion. So let's just look at this fifth power here. You have a to the fifth, a to the fourth, a cubed, a squared, a, and in the very last term, you have no power of a. The last term is b to the n that decreases as you go backwards. So here you're going to have b to the fifth, b to the fourth, b cubed, b squared, b, and then no power of b. The sum of the exponents on the variables in each term is n. So here our n is 5. So if you look, the b here is 5. You have a 4 on the b, a 1 on the a, so that's 5. 2 and 3 is 5. 3 and 2 is 5. 4 and 1 is 5. And that's 5. So there is n plus 1 terms in each expansion. So here we're talking about the fifth power. We have 1, 2, 3, 4, 5, 6 terms. And in the last lecture on binomial coefficients, we said and we showed how to get these coefficients, n combining r or n above r. So the formula for expanding binomials, if you have a plus b to the nth power, these binomial coefficients are n over 0, or excuse me, n above 0, n above 1, n above 2, and all the way to n above n. Okay, now we said that it mirrors Pascal's triangle. So if you know the first 4 or 5 rows of Pascal's triangle, then you can just really list those coefficients down and not have to find them every time. And then we just talked about how to get the powers of A and the powers of B. So let's go in and let's look at an example. We want to expand x plus 4 cubed. So we know it's going to be 4 terms because here n is 3. We're going to have 3 combining 0, 3 combining 1, 3 combining 2, and 3 combining 3. Now, if you go back to Pascal's triangle like we did in the last lecture, we know that Pascal's triangle has that third row is 1, 3, 3, 1, and that's what these coefficients will mirror. The first term in this expansion is x, so we're going to have an x cubed, an x squared, an x, and then no power of x. The last expression is 4, so we're going to have a 4 cubed, a 4 squared, a 4 to the first power, and then no power of 4. And then now we just need to simplify. So 3 combining 0, doing it on your calculator using the formula that we had, or remembering Pascal's triangle, is 1. So it's 1x cubed plus 3 combining 1 is 3. 3 times 4x squared plus, again, 3 combining 2 is 3. 4 squared is 16, and that's x. 3 combining 3 is 1, and you have 64. So this becomes x cubed plus 12x squared plus 48x plus 64. That's our binomial expansion. Let's look at another one. Here we have x plus 3y cubed. Again, Pascal's triangle, 1, 3, 3, 1. we can write this as 3 combining 0, 3 combining 1, 3 combining 2, and 3 combining 3. Our first term is x, so we have x cubed, x squared, x. Our second term is 3y, so we have 3y cubed, 3y squared, 3y to the first power, and then no power of 3y. So 3 combining 0 is 1, so this is x cubed. 3 combining 1 is 3, and 3 times 3 is 9, so this is 9x squared y. 3 combining 2 is 3, 3 squared is 9, and that gives us 27x. Then we have to square that y to get y squared. And then 3 combining 3 is 1, but 3 cubed is 27. Then we have our y cubed. Now, if you notice in the last couple of examples, we had a plus sign in there. All right, so we want to expand this fifth power now using the binomial theorem. And our second term here is going to be negative. This is x minus 3y. So we're going to make the second term negative, and that's how we're going to know what terms are going to be negative and what terms are going to be positive. The fifth row of Pascal's triangle is 1, 5, 10, 10, 5, 1. And you can write your 5 combining 0, 5 combining 1, 5 combining 2, all the way to 5 combining 5. But I'm going to go ahead and just write our 1 here. And then our first power, or our first term is x. I'm going to have x to the 5th. And then I'm going to write my 5, and I'm going to have x to the 4th. And then I'm going to write my 10, and I'm going to have x cubed. And then I'm going to write my other 10. I'm going to have x squared. And then I'm going to write my 5. I'm going to have x. And then I'm going to write my 1. Then I'm going to go back, and I'm going to say negative 3y to the 5th. Negative 3y to the 4th. Negative 3y cubed. Negative 3y squared. Negative 3y to the first, and then no power of 3y. So let's see what we have. We have x to the 5th. Now negative 3y is raised to the first power, so it's going to make that term negative. 3 times 5 is 15, x to the 4th, y. Now negative 3 squared, that's a positive number, so this term is going to be positive. 3 squared is 9. 9 times 10 is 90. We have x cubed, y squared. Negative 3 to the 3rd is going to make this term negative. We have 27 times 10, which is 270, x squared, y cubed. Negative 3 to the 4th is going to be a positive. So we have 3 to the 4th times 5, which is 405, x, y to the 4th. And then negative 3y to the 5th is going to give us a negative number, and that's 243y to the 5th. This is our binomial expansion. So how do we find a particular term? Suppose, you may have a binomial to the 10th power, and you don't need to write all of that. How would you find just a particular term? So you have to break this down to the r plus first term of the expansion of a plus bn. And it is n above r times a to the n minus r times b to the r. So in this example, we want to find the third term. And we have to break down the third term as the 2 plus first term, where our 2 is r. So we have n, which is a 6, above r, which is 2. We have A. A is the first term. That's x to the n minus r. 6 minus 2 is 4. Then we have our second term, which is 2y to the r. Here again, r is 2. So let's simplify. 6 combining 2 is 15. X to the 4th times 4y squared. This becomes 60 x to the 4th y squared. So remember that Dr. LB is always in. Please come back for more math help.